Madungganan ninyo klase ko ang kuan. Tingog. May madunggan nga feedback, no?
Dunggan, ma'am.
Okay. So, let us start. Okay, so this is the last topic that we will have sa Physics 41. And this is actually a very kanang kuan kini siya nga topic as fluid mechanics kay pwede siya himuon natong isa ka subject or sa majors this is kanang isa jud siya ka SEM fluid mechanics. Okay. So here we will have a brief introduction lang sa fluid mechanics. Fluid mechanics is divided into two major branches. So we have fluid statics, and then we have fluid dynamics. Okay. All right. So fluid statics deals with fluids at rest. Fluids at rest or fluids that are in equilibrium. While fluid dynamics deals with fluids in motion. Okay. So at this point na natay Vino, since we are dealing with fluids in motion. Okay. So, by the way, class, what are fluids? Di ba matter can be categorized into 4 major categories. So we have solids, liquids, gases, and then plasma. Okay. Solids, ang mga solids class kay nana siya, it is composed of molecules. It is consist of molecules that are so compact that maglisod sila og move. Okay? Whereas liquids and gases are substances that can flow because ang ilaang the material or the molecules comprising them or they are made of kay dili kaayo close to each other, makamove sila, dili kay compact or they can easily move such that it allows flow. Okay, so fluid flows. All right, so fluids that are at rest or in equilibrium, we can actually describe its interaction with another fluid or solids by describing its density. We have also the specific gravity. So density and specific gravity are physical quantities ni siya class that can be described with a number and a unit. Okay, so we have density, specific gravity, and then we have pressure. Okay, and fluids at rest are governed by, or it follows the Pascal's principle. It obeys the Pascal's principle. And the the Archimedes principle. Okay, so let us discuss each of these later. And then we have fluids that are in motion. So again, nanantay velocity, no? Fluids in motion can be described by the continuity equation. So ilang behavior ay pwede nato ma-describe mathematically using the continuity equation as well as the Bernoulli's principle, Bernoulli's equation. Okay, so let's start with this initial density, specific gravity, pressure, then Pascal's principle, and then Archimedes' principle. Once we know these things, we will then proceed to fluid dynamics. Okay, so we have the density. So, ano man siya yung density class? Density is denoted by the Greek letter rho, and it is the measure of how compact an object is or a substance is. Okay. Now, density is an innate property of a material class. For example, for solids, the density of solids is, for example, na ako'y gold. If you have a pure gold, regardless of shape and sizes, so say for example, you have a rectangular bar of gold, or you have naka irregularly shaped na gold, or bisag naka bracelet na siya nga gold, basta pure lang ni siya nga gold class, any form of gold has constant or the same Resilaw density. So any of these three forms of gold, basta pure lang, parehas lang density. Okay, so it is an innate property of a material, and it is sometimes used to identify unknown materials. So, si density, pwede siya na ito gamiton pang-identify og unknown materials. Okay, so say for example, nakakita ka og object and you want to know unsa to siya. Say for example, nakakita ka gold, naglakaw-lakaw ka, nakakita ka og gold bar, and then you want to verify if it is really gold. So you can actually get its density. So density can be measured by taking the ratio of the mass and the volume of that material. Okay, so for example, bar siya. So the volume can be obtained by measuring it through a ruler. So nakay magkuha kag length, width, ug height ani. So you can get the volume, and then you can just measure the mass of the object by using any balance, triple beam balance, analytical balance. And then in order to get the density, take the ratio of the mass and the volume. Okay. And for example, uh, pure gold has a density equal to 19,300 kilograms per meter cube. Okay, so if you will obtain a density that is equal to or duol-duol ani class, then it could be possibly real gold. It could possibly be a real gold. Okay, so for example, for an object that has a regular or kanang well-defined ang iyang volume o iyang mass, naa siya unique nga density, or each object has a unique density. So for example, this is for gold or copper. If we talk about copper, the density of copper is equal to, I think it's 980. 9,800. 8,900. Sorry, it's 8,900 kilogram per meter cube. Copper, no? Yeah. So this is the density of copper. So any material has a unique density. But there are also materials that are or that has a density that is varying with temperature. Say for example, gases. So gases are materials or substances that are compressible. Readily compressible. So what does this mean? For example, if you subject a gas to a change in temperature, or if you change the temperature of gases from a lower temperature to a higher temperature, for example, then gases will, mag-unsa gani sila class? The molecules of the gas will move farther from each other, thus increasing its volume, pero the same ra ang mass. Okay, so that means as you increase the temperature of gases, the density decreases. So, ma-increase ang volume, constant ang mass, so magamay ang density. Okay, and also if you change the temperature of gases from higher temperature to a lower temperature, move closer to each other ang mga molecules comprising the gas, and then mugamay ang volume with the same mass. Okay, so that means ma-increase ang iyang density. Okay, so for gases or for objects or substances that are readily compressible, ang ilang density is dependent on temperature. So say for instance, the density of air at 20 degrees Celsius is equal to the density of air at 20 degrees Celsius. Pila gani di? Density of air at 20 degrees Celsius? 1 kilogram per meter cube? Okay. 1 kilogram per meter cube. Yeah. 1.01. Okay, it's 1.01 kilogram per meter cube. So this means if you have a box that is, ang iyang dimension is 1 meter by 1 meter by 1 meter, kung magbutang kag air dira at 20 degrees Celsius, ang iyang mass is 1.01 kilogram. Okay? And then if this box is gold, so nakay box nga 1 meter ang side, okay, nakay cube nga 1 meter ang side. If you fill this with pure gold, or if this is pure gold, gold nga cube, then ang mass ana niya class is 19,300 kilogram. Or if this material here is copper, and then ang iyang volume is 1 meter cube, then the mass of this material is 8,900 kilogram. So, pwede na kadili gamit og timbangan. Another thing is, for example, water. So, usually, we have water, pure water. So, the density of water, this is at 4 degrees Celsius, is equal to 1,000 kilograms per meter cube. Okay. Meaning to say, if you have 1 cubic meter of water, ang mass ana niya is 1,000 kilogram. Okay. So take note that the density is the measure of how compact an object is. All right. So we then have the specific gravity. Specific gravity has nothing to do with gravity. It is sometimes called, or it is usually or I think its correct term is relative density because it takes the ratio of two objects. Okay. So for example, okay, you can express it as a ratio of, say for example, any substance with respect to a standard. Okay. Specific gravity with respect the density, the ratio of the density of the substance divided by the density of the standard. So, unsa man yung standard class? So, for liquids, the standard is of course water. So, we know that the density of water at 4 degrees Celsius is equal to 1,000 kilograms per meter cube. And then for gases, the standard is that of air. Standard is air. And the density of air at 4 degrees Celsius, sorry, it's 20 degrees Celsius. 20 degrees Celsius is equal to 1.01 kilogram per meter cube. Okay, liquids and solids. All right, so say for example, we know that the density of gold equals 19,300 kilograms per meter cube. All right. So we want to know the specific gravity of gold. So the specific gravity of gold is equal to rho of gold divided by the density of water. Okay, so this is equal to 19,300 kilograms per meter cube divided by the density of water. It's 1,000 kilogram per meter cube. So this is equivalent to ilan man ni siya class? 19.3. Take note the specific gravity has no units. Okay, so the specific gravity of gold is 19.3. And then let us compare this with ice, the specific gravity of ice. So raw ice, it has slightly lesser density compared to that of pure water. So the density of ice is 900 kilograms per meter cube. Okay. So the specific gravity of ice is equal to 900 kilograms per meter cube divided by 1,000 kilograms per meter cube. So this is equal to zero point 0.9. The specific gravity of ice is zero point 0.9. Now here's the thing, class. You have to take note that specific gravity, which substances or materials that has specific gravity greater than 1 will submerge in water. And then we have specific gravity, substances or materials with specific gravity lesser than 1 will float in water. Okay, so for example, if you have a beaker or a glass that is partially filled with water, and then we put here a small amount of gold. So atong ibutang diri ang small amount of gold, then expectedly the gold will be totally submerged in the water. Now as to the ice, if you can see this in your actual kung namoy kung sige mo og kuan klase inom og tubig na ice, you can actually see that si ice class kay naa siya portion nga naka-float and napon siya yung portion nga naka-submerge sa water. Okay. And actually, the submerged part is 90% of the total volume of the ice. And kining naka-float diri, this is 10%. Okay? So kung ano na siyang mga bantayan, it is partially submerged. Na yung part nga naka-float gihapon. That is 10% lang. So as uh, determined by this, the specific gravity. Okay. By the way, class, the unit of density. So we use kilogram per meter cube. We can also use grams per centimeter cube. Or we can also use grams per ml or grams per liter. Okay. So we uh, we will go to pressure. So for example, class, na po kay fluid diri ah. Say for example, water. Kung naa kay object pressure or na siya ma-feel na pressure. Okay. So this pressure can be quantified. So pressure denoted by P is equal to force per unit area. Okay. So we have F over A. So kining liquid diri or kining substance nga naa diri sa imo ang naa sa imo ang nakasubmerge sa water or sa fluid gas. Kay naani siya ma-experience nga pressure that is equivalent to the force nga gi-exert sa water or sa substance sa iyaa divided by the area. So, unsa man nga area class? The area is kung for example if this is rectangular, then kini nga area itong i-consider this one. Okay? And take note that the force should be normal or perpendicular to the surface area. Okay, take note that pressure is a scalar quantity. So it is a scalar quantity and it has units of Newton units, Newton per meter squared. Okay, or we have Pascal. So other units of pressure class, we have the atmosphere, okay, ATM. So we have 1 Newton per meter squared. This is actually equal to 1 Pascal. Okay. Now, as you go, kung mabantayan ninyo class, as you go down sa pool, for example, kung maligo kag pool, as you go deeper into the water, magka-increase ang pressure nga imong ma-feel. So you can ma-feel na siya nato actually with ma-sense nato ang pressure through our ears. Kung nakabantay mo, kung moadto mo sa ilalom sa tubig, murag masakit inyo ang eardrums or inyong dalunggan. It is actually due to the force exerted by the fluid or sa water towards you. Okay? So as you go down, magka-increase ang change in pressure. And the same with kanang mo go up ka class to some elevation. So say for example, masakay kag airplane and then kung inyo siyang nabantayan, masakit gihapon ato ang dalunggan class or usahay gani kay ma-feel ni siya nako for example kung gikan ko Bukidnon padulong og Cagayan usahay kay na ako'y ma-feel nga pressure sa akong dalunggan pag makanaog na og Cagayan. Okay, that is due to changes in the height or the elevation. So, pwede pa ubos or pwede po pataas. Okay? So, dili mag-matter unsa kadako ang pressure, but ang mag-matter class is the change in pressure. So, say for example, there is a surface of the earth at sea level, the atmosphere, the pressure is very large. Pressure at sea level. It is actually large. It is equal to 1 atmosphere, and this is equal to 1.013 times 10 to the 5 Pascal. So this is a large pressure. Pero um, dili siya nato ma-feel or murag okay ra sa ato ang maglangoy-langoy ta ning atmosphere nga naay ing ani kadako nga pressure because we are inhaling the same air nga naay ing ani nga pressure. So the pressure inside our body is the same as the pressure outside the body. Okay. Now if there are changes in the height, so paubos or pataas, mag-change pud ang pressure class. So we have P, change in pressure can be quantified by this. You have rho GH. It is dependent on the height. So your height can be uh, expressed in terms of the change in Y, the change in the vertical position. So H, where H is equal to Y minus Y naught. Okay. So now take note that this row here, this is not the density of the material nga naaani nga nakasubmerge ani nga fluid or sa ato nga case dili ni density nato. This is the density of the fluid. Okay. So here, if this is water, then the density is 1,000 kilogram per meter cube. Or if this is mercury, so lahi pod ang iya ang density. So the density of mercury, this is the density of mercury. Or if this is liquid sulfur, so init kayo no, liquid sulfur, we will use the density of sulfur. Okay, so this is the change in pressure. Or we can actually rewrite this one. So we know that delta P is just equal to P final minus P initial. So we have P final minus P initial is equal to rho GH. So G here class is the same G that we are using gikan pa sa unit 2. It is equal to 9.8 meters per second squared. The acceleration due to gravity. Okay, so we have P equals P naught plus rho GH. Okay. So, kini siya class, the surplus, kining change in pressure, we call this the gauge pressure. Gauge pressure. And then, your P naught is the atmospheric pressure.
So I still love reports.
atmospheric pressure. And then this one, this is the pressure at a certain height. Pressure at a certain pressure at say for example y at a certain height or at a certain depth or at a certain elevation. Okay? Now take note that kini mo ang atmospheric pressure class mo ni siya no si 1 atmosphere which is equal to 1.013 times 10 to the 5 Pascal. So atmospheric pressure is defined as the pressure at zero elevation. Okay. So that is the pressure at zero elevation. Now, fluids at rest or fluids in equilibrium is governed by the Pascal's principle. So, unsa man ni si Pascal's principle? Okay, it states that the pressure applied to an enclosed fluid is transmitted and diminished to every portion of the fluid and the walls of the containing vessel. Okay, so what does this mean? So, let me just show you this example para mas maklaro siya, no? So, we have here a tube. So, take note that this tube has a circular cross-section. So, mura siya inlet, na po siya outlet. Okay, so according to Pascal's principle, the pressure applied to an enclosed fluid, so let us say we have to fill this up with fluid. Okay, so these are uh, fluids ni siya diri class. Alright. So for example, if we apply a certain force here, F, this force will cause pressure. And the pressure class, we know that it can be quantified by taking the force divided by the area. So we have here the area is the cross-sectional area which is circular. Okay, so if we kung ato ni siya applyan of force, if we want if we apply a force here, so this force will cause pressure. So according to Pascal's principle, the pressure that is experienced by the fluid diri will be transmitted undiminished. Meaning to say, katong pressure nga naa diri is equal to the pressure at any part ani. Okay? Meaning to say, Pascal's principle simply can be described mathematically by this. P in is equal to P out. So for this particular example, we have P in equals P out. Meaning to say, force in, so this is the input force, divided by the area, so kini siyang cross-sectional area here, is equal to, say for example, that is area 1, is equal to F out. So the force nga pwede niya ma-output diri divided by A sub 2. Okay, so suppose uh, this has a diameter or radius equal to R2, and then this one has a radius equal to R1. So we have F input is equal to pi R sub 1 squared. So this is the area of a circle. since we have a circular cross section. This is equal to F out divided by pi r sub 2 squared. Now, si Pascal's principle class actually is grabe siya ka interesting. So, na siya interesting application. It has an interesting application. Meaning to say, even though you exert a small amount of force, pwede ka maka output force or pwede ka pwede ni mo ma-amplify ang force. Okay, so say for example, kung nakabantay mo ka sa mga salon, kung i-lift ka sa barber or karon mo kayo uso kayo ang rebond. Okay, so kung i-lift ka sa barber or sa parlorista, na lang siya uh, gamay lang ang iya ang input nga force. Like for example, na lang siya tumban nga button or kanang button ba na siya? Yeah, brag na lang siya tumban nga button tapos ikaw nga bugat kaayo, say for example you are 50 kilograms. Kung 50 kilograms ka, ang imo ang weight is 50 times 9.8. Pila man na siya? 490? 490 newtons. Dapat may nahanglan ta na siya 400 newtons nga force in order to lift you. But kung inyong mabantayan, igo ra niya tindakan tong button dito malift na dayan ka. So that is actually hydraulics. And it is governed by Pascal's principle. So the same with um, kanang sa mga bus class. Kung mag-open og door ang driver, na lang siya ipindot nga button and open ang door. So, Pascal's principle. For example, kini, nakaingani nga system, we call this a piston. So, nakay i-input nga force gamay, pwede na ka actually makalift og heavy object. So, say for example, sa car, anang mag-lift og car sa mga okay. So tanaw na to class how Pascal's principle work. For example, the input force is 1,000 newtons. This 100 newtons lang class. And then your R1 is 0.5 cm. And then say for example, here kini mo R2 is 20 centimeters. All right. Now, we want to know what is the output force ani nga system, ani nga piston. Okay. So, output force from our equation, P in is equal to P out. We have F out is equal to, we have this one, A2 divided by A sub 1 multiplied by the input force. Okay. So we have here pi r sub 2 squared over pi r sub 1 squared multiplied by the input force. Can actually cancel out pi. And then we are left with r sub 2 squared. So your r sub 2 is 20 centimeters. Since we're taking the ratio of the same ra siya nga quantity, no need for us to convert. Okay, so we have 20 centimeters squared divided by 0.5 centimeters squared multiplied by 100 newtons. Okay, So we have here, pila man ang 200 centimeter, 20 centimeter squared plus is 400, no? 400 cm squared divided by 0.5, that is 0.25 centimeter squared multiplied by 100 newtons. Okay, so we have here, ilan man ni siya class? 400 times 4. So that is 1,600? Sakto ba? Yeah, it's 1,600 multiplied by 100 newton, 1,000 newtons. Now, you have to take note that through this setup, we have multiplied our input force by 1,600 times. So we have here, pila man ni siya plus? The output force is 160, it's 1.1234, 123, so it's 160 newtons. If we divide this by 9.8, so this is the output force, F out. Meaning to say, ang iyaang maximum nga ma-lift nga object kay ang mass equals the weight of the object divided by 9.8. Output. So pila iyang maximum nga ma-lift nga object. So take note, ga-input lang kag force nga ani kagamay 100 newtons. Ang iyang ma-lift nga mass is 160,000 divided by the acceleration due to gravity. So around 16,326.5 kilograms ng object. Okay. So, unsa man nga mga objects class ang pwede niya ma-lift kung nakaing-ani nga anong system. Pwede ka mo lift og elephant. Okay. Do you have any questions?
None so far, ma'am.
Hello? None so far. Okay. So, since hapit na mong time class, we have 8 minutes left. Okay, so let us continue with the Archimedes principle and then maghatag og seat work dayon. Okay, so the Archimedes principle. Archimedes principle. Okay, so the Archimedes principle class is actually the buoyancy, or yeah. So kung for example, kung nakay object, or say for example class, saan man siya? Swimming pool for example. And then kung inyong nabantayan, kung mag-lift mo og object nga naa sa water, kay mas mura siya, ang iyang apparent weight kay mas lesser compared to its actual weight. And that is because of the buoyant force. Okay? So, kini siya, si fluid diri kung naay object, for example, this one. This fluid here exerts a force towards this object. And the direction of this force, we call the buoyant force. Buoyant force. is opposite to the direction of the weight of the object, or the gravitational force. Okay. So we have this one. So if padulong sa ubos ang gravitational force Fg, then the buoyant force is opposite to that. Padulong siya sa north. This is the reason why if you lift a heavy object na naa sa water, its apparent weight is lesser than that of uh, its actual weight. Kaya nga naman, mura ka gitabangan sa buoyant force. Mura siya og nakay force that is opposite to the direction of the weight. Okay. We can actually quantify the apparent weight. So let us define first ang Archimedes principle. So according to the Archimedes principle, it states that when a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body which is equal to the weight of the fluid displaced by the body. So what does that mean? Okay. So take note nga if this is a beaker para na siya kanang calibration class. Say for example, na diri ang water level initially. Okay, na diri ang water level initially. Now if you put something into this water here, unsa may tawag class ani is in the volume of the fluid, because katong imong gibutang diri nga object kay mo occupy pud to siya og the fluid is actually equal to the volume of the object nga imong gibutang diri, or in case nga it is partially floating, or pareha ani kini siyang change in volume diri. This is the volume of the object. This is the volume of the submerged part of the object. Okay? So if it is totally submerged in water, then this is the total volume of the object na imong submerged. Pero kung parehaan ni nga partially submerged lang siya, then the change in volume sa imong fluid is the volume of katong part sa imong object nga nakasubmerge sa water. Okay. So, how do we quantify this one? So, ano siya na to? Pag-quantify class. So, according to Archimedes' principle, when a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. Okay, so we have F, we can quantify it. We can call it F buoyant or F sub B. And it is equal to rho VG. Okay, so this rho here is the density of the fluid. And then is displaced volume, or the change in the volume of the fluid after it has been, or after the object is placed. Displaced volume, meaning to say mo ni siya nga volume class ha, Say for example, this is from 100 ml padulong sa 120 ml. So the displaced volume is 20 ml. Okay, so this is your V displaced. And then your G here is just the acceleration due to gravity. So asa man nigikan ning rho B? Take note that density is equal to mass divided by the volume. So from this, we can get M, which is equal to rho times V. Okay, so this is actually mg. Okay, so mass times the acceleration due to gravity, that is uh, force or weight na siya. So we have in terms of the density, we have rho times V. Mass is equal to rho times V. Okay? So for your seat work class to be submitted on Monday, or dali ra kani siya nga seat work. So Pascal's principle. What is the minimum input force, F input, that you will exert in order to lift an elephant that has a mass equal to to 400 kilograms. Okay. So given R sub 1 equals 1 cm, and then this one is 15 cm, R sub 2. Okay, so this is your seat for class. You can submit this on Monday before our class. Okay, do you have any questions? We will continue with our discussion on Monday. So, ako lang ning isend sa inyo ang karoning notes para makita ninyo ang seat work. Okay, if wala na may questions, class, then you can leave the room.